All right, so here we are with our next speaker, Mete Atamel, with his topic Serverless Landscape Beyond Functions. Welcome, Mete, and the floor is yours. Enjoy.
Okay, uh, thanks very much for the introduction. Hello, everyone. My name is Mete Atamel, and I will talk to you about serverless landscape beyond functions today. But first, let me share my screen and make sure you can see my screen. 1 second. All right, so I think you should be able to see my slides now. If not, please, someone let me know. So yeah, my name is Mete Atamel. I am a developer advocate at Google. And I want to talk to you about serverless landscape beyond functions. And what I mean by this talk is that whenever we talk about serverless, we think about functions because AWS Lambda started the term serverless. But actually, when you look at the last few years, serverless improved a lot beyond functions. There's a lot of things that happened, and now you can run pretty much any kind of workload using the serverless paradigm. So in this talk, I want to talk about the history of serverless a little bit and go through the 4 phases of serverless that I think happened. And then in each phase, I want to explain you what happened, what kind of things we had, what kind of limitations that we had. And then finally get to our phase right now and look at how serverless looks as of today, what kind of things you can do with it. If you want to get the slides, I already have my slides on speaker deck. So if you go here, you can have the slides. If you have any questions, please ask in the chat, and I will try to remember to go and check once in a while to see if you have any questions, and I will also try to answer it in the end, okay? And also, if you have time, maybe I will show you a demo or two as well towards the end of the presentation, so stick around for that if you're interested. All right. Now, serverless, what is serverless? I don't think I need to explain this to you, but it's worth emphasizing that there's 2 ways of thinking about serverless. The first way is what I call the operational model, like how do you run your code? And when you talk about running your code in a serverless way, what we usually mean is that you don't have to care about the infrastructure. So there's some service running somewhere, but it's not your problem. There's some kind of base level security that's given to you. So you don't have to worry about securing a virtual machine, for example. And you expect to pay for what you use. So if you have a service that nobody uses, you don't pay nothing. But if there's a service that people use all the time, then you pay for what you use. So that's kind of the model that we expect when it comes to serverless and how to run our code. On the other hand, you can also think of serverless as how you design your applications. So that's the programming model. And in this model, we are talking about services. So it's service-based that are event-driven. So some kind of event or some HTTP call triggers your service. And usually these services are stateless because in serverless, you have functions or containers or applications or whatever scaling as the demand goes. And that scaling is much easier to do if you are dealing with a stateless kind of service, right? So this is what we broadly mean when it comes to serverless. Now, when we look at the phases of serverless, I think there were 4 distinct phases. The first phase was serverless before it was called serverless. So we actually had some services before and tools that were doing serverless-like things, but we didn't have the term serverless yet. So I just want to talk about that briefly. Then we had the serverless term that came with simple functions. Then after simple functions, we started seeing containers come into the serverless space because containers give us a lot of flexibility on our code. And I'll talk more about this later. And also we started seeing the maturity of serverless. So instead of having simple functions with limited kind of runtimes, we started seeing more maturity around it and more resources basically around functions. And finally, in the last phase that we are in today, what we are seeing is the expansion of serverless and integration of serverless with existing technologies, right? And I think it's a great place to be because I think pretty much anything that you want to do, you can try to do it in a serverless way for the most part, with some caveats that I'm going to talk about. So let's go through this kind of history of serverless and let's see what we had and what were the limitations and what we have today. And by the way, As I go through, I will give examples from services, from different cloud providers. But since I work at Google, I know Google Cloud the best. So my examples will be mostly from Google Cloud. But most of these themes, they also apply to other cloud providers. So I'm not just talking about Google Cloud. It's mostly about the themes that I'm going to talk about that will be relevant. All right, so let's look at the first phase, the pre-serverless phase. And I don't know if anyone recognizes this this logo. Does anyone know what this logo is? Type it in the chat if you remember this. And maybe this is a good time I can actually quickly check the chat to see if it's working. Chat is here. Okay, I don't see anything in the chat. All right, so this is App Engine logo, the original App Engine logo. And App Engine was a service that was launched by Google in 2008. So that was a while ago. And the premise of App Engine was to make it easy for developers to build, manage, and scale web applications. So it was geared towards web applications. And you would write some Python. So Python was only supported language. Run a command line tool to upload your code to Google. And that was it. That's all you had to do. And at the time, this was quite revolutionary because you didn't have to set up service. So there was no service to provision. There was no database to set up. There was an App Engine database that was given to you that you could use. There was no networking to set up because all the networking, load balancing, and things like that were set up for you. So it was quite ahead of its time. It wasn't serverless in the traditional sense, but I think it was fully managed service. So you just deploy your code, and that code is managed for you for the most part. So you might be wondering, like, okay, if it was that great, then why didn't it, start serverless? So let's look at some of the pros and cons of this App Engine era before serverless. First of all, I think this fully managed App Engine paved the way and the vision for serverless. So people could see that, there's a way basically where you can just deploy your code and the underlying infrastructure could actually be abstracted away from you, right? So we saw that it was actually possible. So this kind of made us start to think about this, serverless way, even though it wasn't fully serverless. But the problem was it was very limited in terms of languages and versions. It started with Python, and I think later we added Java. But they were very kind of restricted versions of these languages. And versions of these languages. It was mostly geared towards web applications, so you could only talk HTTP. So if you had to do anything else, it wasn't possible. It was very limited ecosystem. So if you could write your application in App Engine way, and if you could deploy it and use App Engine data store, then great. You get all these benefits of management, basically fully management. But at the same time, you were kind of locked in to this like App Engine way, right? If you had to do some open source, if you want to bring in, for example, an open source kind of service, it wasn't possible. So it very much felt like when the lock-in kind of situation where you had this great service that you could use, but if you want to, and people at the time, they were machines. And these virtual machines were usually not even running in the cloud. They were on-prem, right? So convincing those people to go from on-prem virtual machines to a fully managed App Engine that manages everything was a big step. Like, you can't just drop everything the way you do things and just go this fully managed way because Google tells you so, right? And there was no like gradual path either. You either do it this way or that way, but there was no middle ground. And I think that's one of the reasons why I think App Engine was kind of ahead of its time. And there was no kind of middle ground for people to gradually get there, So that was the time before the term that we had serverless. Now, in the next phase, we started having simple functions, and AWS Lambda came into play, and AWS Lambda introduced the term serverless. Now, in these functions, so AWS came in 2014, then we had Google Cloud Functions and Azure Functions in 2016. But basically, the idea was that you write a simple function in certain languages. Here's an example from Google Cloud where you have a hello world function with a request and response for HTTP, and then you can return a response like this. So it's very easy. You write a function, you deploy, and then the function is maintained for you. The networking is set up, the automatic scaling, things like that, things that you are used to from App Engine, but applied to functions. Now, this was great as a starting point for serverless, but what languages and versions can you use with these functions? And this is a table that I put together probably last month. And when you look at it, some major languages are supported, like Node.js, Python, Go, but not all versions, some versions. And depending on which cloud provider you're using, different versions are supported in different cloud providers. And there are certain languages that are not supported. For example, if you're working with Rust, it's not supported with these functions, at least on Google Cloud, or last time I checked. So as you can see, there's this table that you need to kind of think about and say, okay, is my language that I want to use supported? If so, you use it. If not, then what do? So the languages and versions are kind of limited. Now, again, when you look at these functions, initially they were HTTP based. So you had HTTP calls triggering these functions. And you had some handful triggers as well beyond HTTP. So for example, on Google Cloud Functions on generation 1, you have cloud storage events where someone saves a file to a storage and that triggers an event. It's still HTTP based, but that eventing is asynchronous in the sense that you don't have to set it up yourself, and you just drop the file and all that communication or event happens automatically. Or you had things like PubSub, where you send a message to a PubSub topic, and then that triggers your function on Google Cloud. So there were things like that, but they were very limited. There were only a handful of things that could trigger your function. So that kind of limited what you could do with these functions. And then when you look at the execution model, time and resources of these functions, again, there were limitations. Here, again, I'm giving an example from Cloud Functions from generation 1. The limitations were that it has to be HTTP based. So you cannot do, for example, a background task that doesn't require HTTP. The request time, so when you receive an HTTP request, you need to respond by default in 1 minute. So it has to be for something quick in your function. And you can increase it up to 9 minutes, but it's still not more than 9 minutes. So if you want to do more long-running kind of tasks, it wasn't really possible to do that with the functions. And the memory and the CPU that you get with these functions were limited as well. You couldn't do like very big memory-intensive kind of tasks in these functions either. And also, concurrency was limited with these functions. So there was this one-to-one correspondence between requests and functions. So whenever a request came in, you had to create a function for that request. And then if a new request comes in, you need to create a new function. What this meant is that every request had this penalty that they had to pay to create the function and get the function up and running before you could respond to it. And this could lead to cold start problems, so that the user, when they make the request, they had to wait a little bit of time before they could get a response. There was cold start because concurrency was one-to-one, so you had to create functions all the time. But also there was no notion of minimum instances. So you couldn't say, for example, I want to have 5 functions waiting just in case someone shows up. You couldn't do that. And because of that, you had to pay for this cold start problem, basically. And once you have these functions running, usually these functions, they have a single path. So a path goes to a function. But when you're building an API, you usually have multiple paths, right? So if you want to have multiple paths, then you need to have a way to group these functions. In AWS, there's API Gateway that started in 2015, very early on. And this API Gateway was the only way, and I think it's still the case, the only way to kind of get your functions and group your functions. Now on Google Cloud, the Cloud Functions, they can have public endpoints, so you can get to them without a gateway in front. But at the same time, if you want to build an API, you're going to have 5-10 functions handling each path in the API. And for that, you still need a API gateway or some kind of load balancer in front of them to group them together. So this was the state of, like, the initial state of serverless with functions, and the things that the characteristics of this phase is that, you know, you had these functions, they were managed, which was great, but you could only use them for limited languages and versions, so you couldn't use them for anything you want. You had limited triggers, so it was mainly HTTP based, with some other triggers here and there, but nothing, like, there was not much support beyond, like, a handful of services. What you could run and how much memory you have and how much time you have in these functions were very limited, and this limited the type of workloads that you can run on these functions. You didn't have concurrency, and you didn't have minimum instances, which meant that you had the issue of cold start problems. You know, so your functions could start late, basically, and as a result, users could notice a lag in your functions. And I don't talk about this, but there was also not much local development. So if you want to write your function, run it locally, test it locally, you couldn't really do it in a realistic way. You had to deploy it to see that it actually works. And we had some grouping of HTTP functions, but it was basically very simple path-based grouping and nothing beyond that. There was no complicated orchestration, for example, for your functions. So all of these were kind of quite limiting for this first phase of serverless. Now, in the next phase, we started seeing containers and serverless maturity. Before I go there, let me just double check if there's any question. I don't see any question, so I'll continue. So in this phase, what we started seeing is that, you know, functions are great for simple kind of workloads, but they don't let you run anything you want. On the other hand, we started seeing containers being very popular, and we started seeing services like Kubernetes to run containers. So the popularity of containers was due to because, you know, you could basically run any language, any library you want, and define it in a container and run it anywhere you want, right? So containers give you the ability to create your own runtime and make sure that runtime runs exactly the same way everywhere. So we have these containers and all this flexibility that comes with containers, but then we have the serverless functions that give us all this management for free. And these two worlds were kind of separate for some time. But gradually, we started seeing services like Cloud Run on Google, App Runner on AWS, and container instances on Azure. These services, all they try to do is give you a way to run containers as if they're serverless functions. So give the flexibility of containers, but at the same time, also give you the management that comes with serverless functions. And on Google Cloud, the Cloud Run, the fully managed version, the fully managed service for serverless containers, it's based on Knative, which is an open source project to run containers in a serverless way. So there's Knative, the open source project, and there's the managed version on Cloud Run that's on Google Cloud. And what you get with Cloud Run is that you can run containers, but these containers, it cannot be any kind of container still, right? It cannot be anything you want. It has to be an HTTP-based container that listens on a port. It has to start, this HTTP server has to start in less than 4 minutes. You still have request limitations, so you need to respond within 5 minutes, but you could wait up to 60 minutes. So as you can see, the time limitations are being increased. So now you can run workloads for up to 1 hour, but it's still stateless kind of services because we want containers to scale as well. You can only do things within the request. So you can't do background tasks again. You still have limitations on CPU and memory, even though they're higher now with 16 gig and 4 CPU. And we have things like concurrency that I'm going to talk about. And you also have the ability to listen multiple paths. So in functions, you have one function, one path, whereas in containers, it's a web server, so you can listen multiple paths. And that simplifies things and allows you to run a container without having to need an API gateway, for example. And then concurrency at this stage was improving as well. So instead of having this one-to-one correspondence between request and the function, in Cloud Run and also in Cloud Functions generation to the next generation of Cloud Functions, you see multiple concurrencies. So you can see up to 80 concurrent requests coming into your container, which means that you have less issue with cold starts because you have a container or a function already serving other requests, right? And you also have this ability of minimal instances now. You can set a minimal instance number. So you can say, for example, 5, and that will make sure that you will have 5 containers running at all times, even if there's no requests. So with concurrency and minimum instances, you pretty much get rid of the cold start problem. And there's developments in local development. So with containers, you can build them locally, you can run them locally. With build packs, you can go from your source code to containers in an easy way. And there were frameworks like Functions Framework from Google, for example, to run your Cloud Functions locally. So you don't have to deploy them to see how they work. So you can actually start them and run them locally. There's emulators for services on Google Cloud. And there's services like Local Stack that allows you to emulate any AWS service, basically, so that you can basically set up emulate simulations of services that your functional container needs. And yeah, I mentioned this already, but the other improvements in this time is that you have maximum request processing time increased, more memory and CPU. You have features like always on CPU for background processing, so you can start doing things outside the request thread. And we started seeing richer protocols as well. So far, everything has been HTTP based, but with Cloud Run, you can actually run WebSockets, and you can run gRPC and service and events. So these allow you to basically have more real-time connectivity to your clients. And also with gRPC, you get more efficiency on what goes over the wire, right? So these kind of things becoming more norm in serverless. And you can also kind of start orchestrating your serverless functions or containers. So if you want to run your containers or functions on a schedule, you can do that with Cloud Scheduler very easily. Or if you want to do a task-based scheduling, like for example, a user does something, fills a form, and you create a task and push that task, then that task can go to your function or container quite easily using Cloud Tasks. So these kind of services, and they also have their correspondence in AWS, like CloudWatch and Scheduler on Azure, and AWS SQS or Service Bus on Azure. These basically enable some kind of basic orchestration around our serverless kind of services. Okay, so at the end of this phase, now we can run any language and version with containers, so that's not an issue anymore. We have still limited triggers, so it's still mostly HTTP-based triggers that we had from the first phase. Our execution model and time and resources are increasing, and they're getting better, but there's still limitations that you need to be aware of. So it's still things that you need to know. Cold start is not an issue anymore with concurrency and minimal instances. We have local development options now, so you can test your applications locally, and you can run them locally. And we still have this grouping with API gateways and basic orchestration with schedulers and tasks, but nothing beyond that. There's still not much support for more complicated orchestration that I'm going to talk about next. All right, so now in the last phase of serverless, we started seeing expansion and integration of serverless. So I think there's two things happening right now. One is that, once we have these serverless services running, the question then becomes, how do you connect them? And then we started seeing services. Again, they are serverless services that help you to connect these services in an easier way. So that's like integration of serverless, basically. And also, we started seeing the integration of serverless with existing technologies. So for example, if you want to run a virtual machine, but also combine that with serverless, it's possible to do that today. And I'm going to show you an example of that as we go along. But let me just quickly double check if there's any question. I don't see anything. All right, so let's go through this phase. So once you have your services running, the next question you need to ask yourself is, how do I connect these services together so that they work for a common kind of goal? And the way to connect them, there's two kind of main ways to connect them. One is you can use an event-driven approach. So you can use events to connect your services. So in this case, the services, they don't really know about each other. They don't really care about each other. They just communicate with each other through events in an indirect kind of way. So this allows like loosely coupled services that communicate indirectly. Or you could have an orchestrator, an external service that calls the services in the order that you define, right? So you can have an orchestrator that calls the service A first, then service B first, and service C and D, and so on and so forth. And the advantage of an orchestrator is that you can explicitly define how your services should be called, and the orchestrator makes sure that your services are called in the order you define, and if there's something wrong, it can retry, things like that. So it kind of brings a little bit of order into how your services kind of communicate, again, in an indirect kind of way, because it's the orchestrator doing the work. So these are the two approaches, and depending on which cloud provider you're using, yes, there's a number of services that allow you to do event-driven architectures. So on Google Cloud, there's PubSub to do low-level messaging with topics and publishers and subscribers. And there's EventArc to do a higher-level connection of sources to your services with triggers in the middle. So you create a trigger and you say, I want to connect this service to that service, and then all the events from this service will go to your serverless function, for example. And again, on AWS, there's EventBridge, and on Azure, there's EventGrid to do this sort of things. So this is the event-driven way of connecting services. And when you look at EventArc, what this gives you is basically, now you have the ability to connect Google Cloud or external Google Cloud services to your serverless services. This means like you have much more triggers now. There's a lot of other things that can trigger your service. So you can pretty much connect anything to anywhere you want. And that's a lot of flexibility compared to before. Now, in the orchestration camp, on Google Cloud, there's something called Workflows. It's an orchestration service that allows you to take, like, let's say, to take a flowchart like this and convert that into an orchestration. And Workflows will make sure that this flowchart basically gets called in the order that you define. So it will basically go to your DB and read and lock your inventory. Then it will check for the stock. Then it will call external services. So it will do all that for you in the orchestration that you define. And again, on AWS, there's step functions to do this kind of thing. On Azure, there's durable functions or logic apps to do this sort of thing. So again, there's options in each cloud provider. And the way you define these orchestrations is there's a YAML or a JSON syntax to define orchestration. There's each steps that you define. For example, if you want to say, I want to call these 3 services in this order, you can define 3 steps. You can define what happens in each step. So we are making HTTP post calls to this URL, which is the URL of this service. Then pass in this input, and then the result will be captured here. And then we'll make a call to the next service with the result from the previous step. So you define it that way, and then when you run the orchestration, it will do that for you automatically. And you can also combine event-driven with orchestration. For example, I have this example. Maybe I will show you. I will show you a quick demo now. But basically, in this example, we have users that save some images to a storage bucket. And that image triggers an event, a new object creation event. And that event goes to, and that event is captured by EventArc and passed to Workflows, right? So it's event-driven in that sense. And then from Workflows, we put together a workflow with 4 cloud functions. The first one is filter that checks whether the image is a safe image or not. The second one is a labeler that takes the image and extracts the labels out of the image using machine learning. The third one is a resizer that resizes the image into a smaller version. And the last one is a watermarker that takes the labels from this labeling function and adds that on top of the image. And then it saves the image to the output bucket. So as you can see here, this is orchestration in the sense that you have these functions that are that are supposed to be called in a certain order, we put that into an orchestration, but it gets triggered by an event. So event-driven orchestration. And actually, let me show you an example of how to set this up. So I have this on GitHub if you want to take a look later. But the way we set this up is quite easy. First, we deploy our services. So here I'm deploying my function, the watermarker, then I deploy resizer, then I deploy labeler, then I deploy the filter, right? So these are just plain functions that I deploy. Then I define my workflow. And the workflow is defined in a YAML. And first, we get an event from event arc when the file is saved. From the event, we extract the file and the bucket name. So that's which file triggered this event. Then we pass it to the filter function. This filter URL will be the function that we'll pass. And then we'll just say, OK, here's my file, just filter it. And we get the response. Then we check if the response says it's safe. Then if it's safe, then we call the label function. And again, we get the label response. Then we call the resize function. Then we get the resize response. And then finally, we call the watermark function, where we pass in the file, we pass in the labels, and the watermark will basically take the image and add the labels as watermark. And finally, we just return the HTTP code from each function. So I actually have this workflow here, and I think we have time. So let me just run this just to show you. You can see if I look at the source, this is the definition. I can see how this happens. Like there's a visual representation of my workflow. And I can see an execution. So I ran this before, so I will see the execution here. But let's just actually go to a storage bucket and just upload a picture. So there's an input bucket. So I will just upload a new picture here. So let's upload this picture. This is uploading. And as this is uploading, let's go back to workflows and see what happens. So now the picture is uploaded. And if you look at here, there's an execution that's active. So it's running right now with all the steps. And if you look at the logs, we should see some logs here. Maybe logs don't load right away, but here you should be able to see some logs of your execution. See, I see my bucket, my event, but this execution, it's still active. Once it's done, yeah, it succeeded now. You can see the input. So this is the bucket, and this is the file that generated the event. So I will log that, and the output is just the HTTP code of my services. They're all 200, meaning it successfully ran. And if we go back to our storage and look at the output file, you see that I have this beach 400 to 400. That's the resize image. That's the labels extracted from the image. And then if we open this image, we should see the image that's the bottom sky. These are the labels extracted from this image and overlaid on top of the image. So you can see how that works. All right. So that's one way. So you can combine event-driven with orchestration. You can also combine serverless with serverful. So what I mean by that is that let's say you want to do a long-running kind of operation. You want to calculate something like a prime number or something that will run for days or even weeks, right? You can't do that with serverless today because there's limitations on how long you can run these things. But what you can do is that you can create a VM, run what you need to run for however long you want to run, and then get the result from the VM, and then shut down the VM. So you can automate this whole life cycle of a VM using workflows, right? So in this case, workflow will basically automate this, run the code on a VM, get the result, and then come back. And in the end, you won't have any servers running anymore. So it almost feels like serverless, but at the same time, you are running a server. And actually, I have another example. I won't run it, but if you can check it out. It's on GitHub. Basically, I show how to run a long-running container with workflows and compute engine. And if it calculates a prime number. And if you look at the source, basically what it does is that it initialized, it creates a VM, then it waits for VM to be ready, then it calls the VM to start the long-running operation, in this case calculating a prime number. It waits for it for some time that we define, like let's say a day or two, and then it stops the work, and then in the end it deletes the VM. So all the workflow is there, it deletes the VM, but in the end what you get, and I ran this before, if you look at the execution, you can, for example, see I'm creating an instance with this name, a new VM, and I run it for 60 seconds, and the VM will be created, it will run for 60 seconds, and in the end, it will give me an output that's the prime number that it calculated in 60 seconds, right? So in the end, that's all I get, but there's a lot of things happening in the background, but Workflows kind of handles that for me. So that's how you can kind of combine service with serverless. All right. And there's also work to enable non-HTTP containers, because right now everything is kind of HTTP based, and everything has to be triggered by HTTP. But sometimes you want to just run a container and run it to completion. Let's say you have a container that reads some files from a database in batches and calculates something and then writes them back, right? So that needs to just start, do the work, run, and then when it's finished, it should just go away, right? There's no HTTP mode there. So it's more like a job, basically. It's like in Kubernetes, this is called a job. So there's now work in serverless landscape to enable this kind of workloads where it's basically run to completion containers kind of jobs. And on Google Cloud as well, there's a service that we are working on to enable this kind of use cases. All right, so the state of serverless as of today, in my opinion, is that you can pretty much use any language and version you want. You have rich triggers, so you can pretty much connect any service to your any serverless service that's running. You have limitations still on what you can run on serverless, but those limitations are much more than before. Like much more in the sense that those limits are much more, so you can run more things, but you can also combine other things like service so that you can run pretty much anything you want that gets kicked off from a serverless kind of service. You don't have cold start problem anymore. You have local development, and you have this rich orchestration options that allows you to kind of combine these services again in a serverless way. So I think they're in a much better state now. And I didn't even talk about other services around serverless, right? I mean, all this stuff that we talked about, it's about running your code in a serverless way, and then kind of combining them in a serverless way. But in the data layer, like, if you want to run a NoSQL database, for example, there's serverless Google Firestore or Amazon DynamoDB, or on SQL, there's like Spanner and other SQL databases from Azure, which is not fully serverless, but it's kind of fully managed, so it's kind of close to serverless. There's caches like Memory Store or Azure Cache or whatever, and there's services such as SendGrid, Twilio, that lets you send emails or make calls because there's services to do that. So you don't need, again, you still don't need to kind of worry about setting a VM to send an email or anything like that. So whenever you are designing your service, you need to think about these things too. And it would be a shame, basically, to design your whole system in a serverless way, but in the backend, it relies on a SQL database that you need to maintain. That would be kind of, like unfortunate, because in the end, like you have all the benefits of serverless on the front part of the application, but in the backend where you have your data, you still need to worry about servers and instances. So there's options in that space as well, but this could be another talk. So that's why I just want to mention them here and just let you think about them at the end of this talk. All right, so this is all my talk. As I said, if you want the deck, it's here in my link. If you have feedback for me, please send me feedback about the talk here, about what you like, what you didn't like, and what you want to hear more, and I'll be happy to take a look. I always like to hear feedback. I will quickly check if there's any question. Yes, so someone is asking, can the workflow be dynamic or parameterizable in some way? Yeah, I mean, you have parameters passed into a workflow. You can do that. And these parameters you can define them as you run your workflow, right? So when you deploy your workflow, and then when you run it, you can pass in parameters, and these parameters can be read by workflow and it can be acted upon, right? So so definitely it can be parameterized. And okay, so there's more explanation. I mean, in the case of batch job where you have to iterate through a list, maybe orchestrate the processing of each element in separate function, then when all are ready, process all the function results. Yeah. So what you mean is that, so you have a list and you want to orchestrate that list, running that list, and do that in kind of like a parallel way, right? I think that's what you mean. Today, the workflows, it doesn't support parallel. So what you can do is you can do a for loop, and you can call cloud functions, but you need to do it one by one. But we are working on a new feature which is called parallel branches in workflows, where you can do that for loop, and either within workflows or by calling a cloud function in parallel, right? So that will allow true batch processing, where you can take your data, divide that into 10 pieces, and then run each piece in parallel. And when the results come back, you combine them into a result in the next step. So that is coming very soon in workflows. Okay, so that was just remark. And then the last question is that there are a lot of product services available from all cloud providers. For someone new to the scene, they seem overwhelming. It is overwhelming, I agree. It is hard to know what you need to learn in order to be able to tackle your problem. Yes, any suggestions where to start, how to navigate through the initial learning curve? Yeah, that's a really good question, and I totally agree. Just forget about all cloud providers. If you just focus on one cloud provider, for example, Google Cloud, even there's so many different services for so many different things, and it's kind of hard to know what to use when. So unfortunately, I don't have a quick answer where I can say, okay, just do this and it will be clear. What I can suggest is that I guess you need to pick a cloud provider, right? I mean, you can't work in all three cloud providers. So just pick one first, and then also pick what you want to build. Don't try to learn everything because it's impossible, but pick what you want to build. Let's say you want to build a web kind of application that has a simple front end and it has a back end, something simple like that. Then from then on, just focus on each part. Like, for example, for the front end, if you want to write it in Node.js, then look at your options. Like, okay, if I want to run Node.js, what's the easiest way to run Node.js on Google Cloud, for example, right? And the options there is limited now. Now you can run Node.js in Cloud Functions, or you can run it on Cloud Run because it's a container, or App Engine, right? So then you kind of narrow down these three services, and then you can look at these three services and see, depending on what you want to do, which one makes more sense, right? So if it's just a simple function kind of thing, maybe Cloud Functions will be enough. But if you want to build a web API, maybe you need to do it in a container and run it behind Cloud Run, right? So you can focus that way. And same for the data layer, right? If you want to use a SQL database, or could you use NoSQL? Because if you could use NoSQL, then that means you can use Firestore, and that means it can be kind of serverless, right? So you can kind of narrow down parts of your application and then just search those services for those parts. And with that, you will gain more experience. So I think that's the way I would do it. Just try to build something and see what services exist for which part, and just do a little bit of research and figure out what works and just go with that. And at some point, if it doesn't work, then you need to switch to some other technology. So just give it a try like that, and hopefully that helps. Okay, I'm out of time, so thanks very much for listening. Hopefully this was useful to you. And if you have any questions after today, feel free to reach out to me on Twitter, and I'll be happy to answer. Enjoy the rest of the conference with the last few talks that's remaining. Again, thanks very much for listening.